Hey, geometry students. Here we're in section 13-1, and we have some new vocabulary. And we have sample space, tree diagram, a two-stage experiment, and a multi-stage experiment, and then the fundamental counting principle. Okay, here's our first example. One red token and one black token are placed in a bag. A token is drawn and the colors recorded. It's then returned to the bag and a second draw is made. Represent the sample space for this experiment by making an organized list, a table, and a tree diagram. Alright, so this first one's going to be an organized list. So we're going to pair each possible outcome from the list, from the first drawing, with the possible outcomes from the second drawing. So we could have RR, RB, BB, or BR. Now in table format, it's going to look similar. Outcomes. We could have the first drawing in the left column, and then the second drawing along the top row, and then we can have kind of like something called a two-way table. We also can demonstrate this through a tree diagram, where we have the first draw being the R or the B, and then if a R occurs on the first, then the second one could be an R or a B. Therefore, you kind of follow the path. We have an RR outcome, an RB outcome, a BR outcome, and then finally a BB outcome. Alright, check your progress. Go ahead and pause your video. Alright, so choose the correct display of this sample space. So we have YY, YB, BY, and BB. So if you notice, the A and the B, they are missing something. Okay, you notice the B is missing the BB. Okay, so it looks like they made a mistake here on the bottom right hand side. Oops. Should be right here. And think about this one right here. What's wrong with that one there? So it shows B and then followed by a yellow. Okay, here's a real-world example of a multi-stage tree diagram. Chef salad. A chef salad local restaurant comes with a choice of French, ranch, or blue cheese dressings, and optional toppings of cheese, turkey, and eggs. Draw a tree diagram to represent the sample space for salad orders. So we have 4 stages. We have the dressing, FR or BC for blue cheese. We also have the cheese, or no cheese, turkey or no turkey, eggs or no eggs. Now we're going to draw a tree diagram with the 4 stages. Sometimes you have to draw them to the side to make them bigger. So think about what this stands for. This top one being F. Okay. Think about what that stands for, right? That's going to stand for the French dressing. Okay. Oops. Go back. French dressing. followed by having cheese and turkey and egg. So the outcome FCTE is one of the outcomes. Look how many outcomes we can have. 1, 2, 3, 4, 5, 6, 7, 8. 8 here and 8 here. That ends up being 24. Okay. So we have 3 choices of dressing. We have 2 choices of cheese, no cheese. We have 2 choices of turkey, no turkey. And finally, 2 choices of egg, no egg. 3 times 2 is 6, times 2 is 12, times 2 is 24. You'll see that coming later. Okay, check your progress. Okay, go ahead and pause your video and answer the question. Okay, how many stages are in the sample space? There are going to be 5. Purchase a hot dog, bratwurst, or tofu dog. This comes with optional choices of ketchup, mustard, onions, or relish. Okay, so you have 5 stages. Okay, fundamental counting principle. The number of possible outcomes in the sample space can be found by multiplying the number of possible outcomes from each stage. So, in the previous problem, I had multiplied. We had the 3 dressings times the 2 cheese, no cheese, times the 2 turkey, no turkey, times the 2 egg or no egg. And that gave us the total. We knew that there would be 24 possible outcomes in that sample space. Okay, using the fundamental counting principle. New cars are available with a wide selection of options for the consumer. One option is to choose from each category shown. How many different cars could a consumer create in the chosen make and model? Alright, so exterior color 11. So we have 11 choices. Okay. So we have 11 choices. And then we can multiply it by 7 interior colors. And then 5 different seat materials. And then 3 different engines. 6 different computer navigation systems. 4 different wheels. And then finally, 3 types of doors. We're going to multiply all this. It's going to be nice and large. So using the fundamental counting principle, we have 11 times 7 all the way down to our times 3, 83,160 possible different vehicles that you could make. Okay, check your progress. Pause your video. Use your calculator if needed. 3,888. That'd be 9 times 3 times 3 times 4 times 2 times 3 times 2.